Hello everyone, welcome to our new video on number conversion. In this video, we are going to convert a given decimal number into its equivalent hexadecimal format. So watch the video till the end to learn how we can convert a decimal number to its equivalent hexadecimal format. A decimal number has 10 digits from 0 to 9 and hexadecimal number has 16 digits 0 to 9 plus A to F. So altogether 16 digits are there. Now we can convert any decimal number into its equivalent hexadecimal number, and for the procedure we are going to just recall the same procedure that we have followed in decimal to binary conversion or in decimal to octal conversion. So we have used there the repeated division method. Here also we are going to use the same procedure, repeated division method, where we are going to divide the given decimal number by the base of the hexadecimal, which is equals to 16, and each and every division process we are going to collect the remainders. Now simply finally we are going to just collect all the remainders from top downwards to upwards order. From bottom to top order we are going to collect all the remainders to get the hexadecimal equivalent of the given decimal number. So let's start with the given number. We have given here a number which is 423 in decimal. So we are going to divide this number by the base of the hexadecimal, which is equivalent to 16. So here the quotient that comes as 26 and the remainder will be 7. So again we can further divide this number. So it goes 1 times, and here the remainder is 10, but instead of 10 we are going to write the symbol A, because A represents 10 in hexadecimal. So if we have the remainder like 11, so we are going to write that letter B, because B represents 11 in hexadecimal. So in any case, while in repeated division procedure, if we got a remainder between 10 to 15, it can be possible. So if we got a remainder between 10 to 15, we are going to write the letters A to F, any one the letters between A to F according to the remainder what we have got. So here we have got the remainder as 10, so for this reason we have written this A. Again we are going to further divide the number 16, the number 1 by 16, so it goes 0 times and we left with remainder 1. So this is our remainder, and we are going to collect the remainders from bottom to top order. So therefore the given number 423, the hexadecimal equivalent of the given decimal number is 1A7 base 16. This is our answer. So as we know that the decimal number has two parts, integer part as well as the fractional part. So it may come the decimal number as a fractional part. So this part can also be converted into its equivalent hexadecimal number, and we are going to follow the same procedure like that we have done to convert a decimal number into its equivalent binary form or in octal format. We have just multiplied the decimal number by the base of the binary and octal or octal. So here we are going to do the same thing. We are going to multiply the given decimal number by the base of the hexadecimal. So we are given the number as 0.23, and we are going to multiply the number by the base of the hexadecimal, which is equivalent to 16, and we will get the result as 3.68. So from this multiplication result we are going to just collect the left part of the point, this part, this integer part, the left part of the decimal point. We are going to just collect this thing, so 3. Now if we take out 3 from 3.68, we are left with 0.68. This again we are going to multiply with 16, and we will get the result as 10.88. Now if we take out 10 from this number, we will left with 0.88 but when we are taking out the 10, so we write here A. Instead of 10, we are going to use the letters that are in hexadecimal. We will write A here. So now again 0.88 multiplied with 16, we will get the result as 14.08. So again, instead of 14, since we are taking out 14, so instead of 14 we are going to write the designated symbol, which is E. E means 14 in hexadecimal, so we are going to write the symbol E. Now we are left with 0.08, which is further again multiplied by 16, we will get the result as 1.28. So we are taking out 1. So we are going to stop the process here, and the hexadecimal equivalent of the given decimal number is equivalent to 0.3a E1 base 16, and this is our approximate result. Because it's a never ending procedure, so we will just do a 4 to 5 steps and we will stop the result multiplication process, and the result that we have got, which is correct up to 4 significant digits after decimal. So this is the way we can convert a decimal number into its corresponding hexadecimal format. So now we are given a number 214.25. This we have to convert into its corresponding hexadecimal format. So the left part of the decimal point, which is 2 or 4, we are going to divide this one by the base of the hexadecimal, which is 16. So it goes 13 times, and we have a remainder which is equivalent to 6. So this can be further divided. It goes 0 times, and we have 13. So instead of 13, we are going to write the symbol which is equivalent to D, and we are going to collect this from bottom to top order. And the right part of the decimal point, we have the number 0.25. This will be multiplied by the base of the hexadecimal number, which is equivalent to 16, and if we multiply 0.25 with 16, we will get the result as 4. So now we are going to take out this number 4, and we left with 0.00. So here we will stop the procedure, since we have occurred the number 0.00, we will collect the integer part from top to bottom order. So therefore we are given a number 214.25 in decimal, and the hexadecimal equivalent of this number is, first we are going to write out the hexadecimal equivalent of this one 214, which is D6 from downwards to upwards order, and then we are going to write down this part, the fractional part just we have obtained here, which is equivalent to 4. So D6.4 is the hexadecimal equivalent of the given decimal number 214.25.
Thanks for watching the video. If you like the video, then hit the like button. If you are new to the channel, then subscribe the channel and hit the notification bell icon for regular updates.